So I'm going to be talking about the Australian context, and in particular about a program for teachers that I helped to set up with colleagues here at the University of Sydney. I'm going to talk a little bit about our data collection strategy and present some brief case studies of some of the schools that have been able to bring about change in girls' attitudes and aspirations in STEM. And finally, perhaps highlight some curriculum impact factors that we've been finding in our research so far, although it is early days and this is a work in progress. So if I switch now to the situation in Australia regarding females in STEM, I'm going to draw on some data from this particular research report that drew on many studies to summarise the situation in Australia regarding girls in STEM. And I think there are 9 or 10 points that I'd like to just highlight. Well, first of all, female students are less interested and less confident in STEM subjects compared to males, and you can see the data presented there. Secondly, when considering the importance of STEM knowledge for future employment, female students consider technology as the most important and engineering as the least. Next, when asked what type of career they would like to have in the future, twice as many male students aspired to a STEM-related career than females. In 2017, despite having similar average performance, fewer girls achieved at the highest levels in NAPLAN numeracy tests. They are our national tests that are held every year in Australia. Female students are enrolling in Year 12, which is the last year of schooling, in technology subjects at much lower levels than males, and rates are actually declining. Completion of tertiary STEM education, particularly engineering and related technology studies, is far lower amongst women. Of the STEM qualified population, women comprised only 17% in 2016. In academia, women are underrepresented as a total of STEM academic and research staff and in senior positions. In the broader workforce, women are particularly underrepresented in engineering and IT. Women earn less than their male counterparts in science, engineering and IT roles. And the visibility of women working in STEM careers is poor. So that paints a rather bleak picture, and I know that there's some synergies between the data I've presented and those presented by Professor Kim. In New South Wales, in the context, the state of New South Wales, the context in which I've conducted my research with schools and school teachers, a couple of highlights. We have certainly had declining participation in senior school STEM subjects. Now, that actually includes mathematics and science, which are not compulsory in my state, and indeed in most states in Australia. We have continued poor attitudes and engagement in mathematics for female students, and we have lower expectation one slide too fast, lower expectancies for success in mathematics and science for girls, and lower aspirations towards STEM careers. So we've actually got a lot to think about. How do we address these issues? Well, schools and teachers can't address all of those issues, but we can do some things, we believe, to try and turn around attitudes and aspirations. And one of the areas that we're trying to focus on in our professional development program is through the curriculum. And we're hoping that teachers will join us in a journey of curriculum change to inspire their students into STEM. Now, STEM has been quite popular in Australia for about the last 7 or 8 years, but there's a lot of extracurricular work going on. There are lots of clubs and competitions. There are lots of external providers, and these are very good, but they tend to attract the students who are already interested in the STEM fields. We're keen to try and broaden our reach of STEM, and so we would prefer to look at how we can embed more STEM experiences into the curriculum, whether it's on an irregular basis where we might have guest speakers in subjects or one-off STEM project days and events, or whether it's more ongoing and embedded in curriculum through shared integrated STEM projects. Some schools have designed new curriculum, and they have, for example, one particular school, a teacher designed an integrated program for grades 9 and 10 students, but it was an elective and it was targeted at talented students. You'll notice from the names of the modules in these two year groups that there's very much a strong engineering focus. The school embarked on this endeavour because they wanted to promote STEM to their gifted and talented students, the students that were already good at maths and science and technology subjects, but they wanted to encourage more of them to participate in these subjects in years 11 and 12, and also to continue on to more STEM in university. Now, the school was very successful. They did, in fact, achieve that goal. So as a consequence, a lot of other schools in New South Wales have been introducing this STEM elective in grades 9 and 10. But in our STEM Enrichment Academy, we're actually trying to get teachers to design a STEM curriculum that's suitable for their students. So in other words, not to implement one that another school has necessarily designed, but to try and implement a program that's going to meet the needs of their students. We began our work in 2015 with secondary schools. We then progressed into primary schools, and finally last year we introduced a connected program where a high school with some of its feeder primary schools worked together as a team to design integrated STEM. Unfortunately, last year, the COVID-19 pandemic interfered with our program, and we weren't able to continue that till the end of the year. Hopefully, we'll be able to reinstitute that going forward. The main features of our program are that it's whole year professional development. There are 5 full days of professional development over the whole school year, but in between the face-to-face professional development meetings, we have school mentoring. So we have a very experienced team of STEM mentors who visit schools and work with the teachers in their school teams to help them address any issues that are arising and to help them to implement their program as successfully as possible. Each school sends a STEM team of 2 to 6 teachers to our program. That depends on the size of the school. So small primary schools might only send 2 teachers, whereas larger schools would send 6, and typically a secondary school would send 2 mathematics, 2 science and 2 technology teachers. Each program would have 10 to 15 schools. Teachers co-design their integrated curriculum to meet their students' needs with an aim to promote STEM aspirations and more positive STEM attitudes. This slide just gives you an overview of the numbers of teachers and schools we've been working with throughout those 6 years. So we've reached more than 1,200 teachers in more than 260 schools in that time. Our data collection includes surveys of teachers, surveys of students before and after the program. Parents are invited to complete the survey online, and STEM leaders and principals are interviewed. So for student data, we actually have adapted the Douglas and Strobel attitude survey and used some more common Australian terminology, but also we've had some open-ended questions. Now, quite clearly in looking at the data from the student survey, there's a lot of variability across schools. In some schools, we find that girls' attitudes and aspirations improve more than boys. In other schools, we found the opposite. In some schools, both gender groups improve with no really significant differences. And then, unfortunately, we've had a handful of schools where there hasn't been an improvement. So there's a real variability across the schools in the sorts of changes they've been able to bring about. So as a consequence, we've actually had to go in and look at case studies to try and ascertain in the schools where the girls' attitudes and aspirations have improved, what are some of the common elements that we can identify? And that's what I'd like to just share with you now by sharing some case studies very briefly in order to bring out and highlight some of those common elements. So the first is a primary school, Sturt Public School, which is in a regional location in New South Wales. The school decided to adopt a whole school Sturt Cares approach. So each class within the primary school actually had to decide what their focus of their STEM project work would be. One particular class, Acacia, which was a grade 2 class, decided with their teacher that they wanted to clean up the school playground and they wanted to look at recycling plastic bottles and plastics and brown paper, etc. And they wanted to teach the rest of the school about recycling. So they went to the local council and got some recycling bins. They had people, experts, come in and talk to the class about recycling. They visited a recycling plant to find out what happens to plastic bottles. And they decided that they also needed now to pitch this to the whole school. So to help the kindergarten children, they wrote a book called Rad Reese to the Rescue, and you can see the cover there. In that, they used a cartoon, and Rad Reese was a cartoon who taught the kindergarten children about recycling and told them what products they could put in the recycling bins. They featured on an Australian ABC program called War on Waste, and you can see the video at that link. Another school that focused on recycling was Lane Cove Public School. They actually watched some of the episodes of War on Waste and were absolutely, the grade 4 children were very upset about the amount of discarded clothing that was building up in landfill and that took a long while to break down. So they wanted to come up with a project on how they could recycle old clothing. And they decided to make shopping bags, recyclable shopping bags from old T-shirts, which they did. They developed a workshop, they designed these products, they took them to the local supermarket where people could use the recyclable bags if they made a coin donation. The students then appeared on the same ABC show, War on Waste, to tell the community about what they were doing and why they were doing it. They also presented to the whole school and got lots of recognition for their efforts. The girls in particular were very keen on this project and certainly drove the community engagement. Another primary school, which is in another regional centre in New South Wales, where in fact there's a lake in the middle of the town which is prone to flooding. Now in New South Wales at the moment we've had a lot of rain and there's a lot of flooded areas, but the students were very keen to learn more about why there's flooding in the town. How come the floods impact so badly on the local shopping mall and the shopping centre? And they wanted to learn more about flooding, about the sorts of vehicles and objects that will float, the sorts of things you could use to help people in a floodplain area. And again, they had experts come into the school and talk to the children about the sorts of vehicles that had been designed and created to help in the floods. They investigated what materials float. They then went on to a bigger project where they were tasked with designing small shops or market stalls that could be readily removed from beside the lake where they usually had their markets when the floods came. These stalls had to either be readily moved or they could float. And it was a project that really inspired the students to actually learn a lot more about maths and science and technology, which went beyond the curriculum for their group. These students were in grade 4. And certainly the challenge took them beyond what they would normally learn in those years. Then if we move to some high school examples, Avondale is an independent school in another regional area of New South Wales. They started with a Mars rover project, and they had the driving question, what advice would you give Elon Musk about colonising Mars? What sort of vehicles could we design to go across a very uneven Mars surface? What sort of dwellings might we be able to build to actually sustain this environment on Mars? And again, the students learnt maths and science beyond the curriculum to design their Mars rover vehicles. They worked in small groups, they designed vehicles using robotics, they tested them on uneven surfaces, and then wrote reports about what they'd learnt. After this particular project, they then went on to a sustainability project where they had to also design ways that they could reduce waste, not just in the school, but also in the local community and indeed in their homes. Another school that started with a space project, if you like, were investigating that a NASA astronaut had been trapped on a newly discovered planet, and they had to design and deliver a new shelter to him so that he wouldn't run out of oxygen. They investigated design and constructing rockets in their technology classes. They tested materials for rocket construction in their science classes. And in mathematics, they designed a Mars calendar. All of these particular projects and programs went again beyond the curriculum. For this particular school, the idea was driven by the deputy principal, who was very concerned that the students had very negative attitudes to maths and science in particular, that they weren't selecting maths and science in senior school, and in fact, very few of them were going into STEM-related careers. By completely redesigning the school curriculum and connecting maths, science and technology right across grade 7 and grade 8, he found that the students' attitudes completely changed. All of them were far more positive, but in particular the girls were far more interested in STEM careers going forward. The final school that I'd like to highlight for you is a very interesting case study. This is a girls' high school in Sydney. It's a selective high school. So the students who attend this school are all gifted and talented students. They are very good at mathematics and science. They're high achieving, but they all prefer traditional learning approaches. What's interesting is that a lot of them actually continue on to tertiary STEM pathways. So when they joined our program, I was very interested to know why they wanted to design integrated STEM curriculum. And the teachers told me that while these girls are very successful, they're very successful at traditional STEM subject work. They don't like doing integrated projects at all. They don't like doing unfamiliar problem-solving tasks. They prefer to be guided by the teacher in their work. They're not good at risk-taking. And so they wanted to introduce project work, integrated STEM project work to the students from grade 7 right through to grade 10 to improve that aspect of the students' learning. They wanted them to engage in projects that involved more risk-taking, that involved innovative thinking, creativity, resilience and collaboration. One of the projects that they designed was a sustainable house project for Year 10 students. And this is a small sustainable house that the school, with the support of the parents, bought and put on their school site so that the girls could actually look at this prototype of a sustainable house and learn about some of the features. The girls visited local houses that had high sustainability measures to see what sorts of features the houses had. They had guest speakers from the local community. So that's just 6 examples of schools that have had an impact, a very high impact actually, on girls' attitudes and aspirations. In fact, for the co-ed schools, they impacted all students, but particularly the girls. And if I was to summarise some of the key factors at this stage that we think are evident in this work, all of the programs were quite aspirational. And in fact, the maths, science and technology that the students were learning and using was often beyond the regular curriculum and what they might learn in that year group. They frequently had a sustainability theme, which is probably not surprising, as that's a cross-curriculum priority area in the Australian curriculum. They often involved projects that had a social impact. They involved creativity, collaboration and challenge. There was typically community engagement, either with the parent community, the local community, or even more broadly than that. In some of them, there were female role models that were brought into the school to talk about the STEM careers and the applications of STEM in the broader fields. And we think that that actually helped the girls see themselves as potential engineers, technologists, mathematicians, and scientists. There are potentially other factors, but at this stage, we think that these are some of the things that are really helping to inspire these girls. So that's where our program is up to at this point. I have listed some publications on the final slide that may be useful to some of the audience. But thank you very much for the opportunity to share this work on behalf of myself, but also my colleagues here at the University of Sydney. Thank you very much.